Oh my gosh, that was close, that was close. Hello world, Wave Time here, bringing to you another idiotic episode of EEPower. So, I proceeded to go in here and jump, trying to go over here, and I didn't realize I did not have my electric jetpack on. Hooray for idiocy. So, I did take your suggestion and I crafted the sonic screwdriver. Making sure I can hover. Yep, okay, we're okay. I crafted it and let's go over here to show you the results of our hard-earned work. Ready? 1, 2, 3, right click. Shift right click. Left click. Nothing at all happens. Stupid thing. So, obviously it's still bugged, so I'm going to go into MBT edit to edit this thing, and then I crafted a lot of wires. Unfortunately, I can really craft these in only sets of 12, so I had to make do with those, and I could have just used dye. Dagnabbit, that could have worked. So I'm going to change this to IO expander number 15, and then we'll be able to readily get everything else ready so we can get the temperature and humidity tolerances ready. That's a problem. So I just edited that, and apparently the maximum is not 255, or rather 256, as I originally imagined for IO expanders. It's actually a bit less than that, which is 127. Which is a bit of a problem because our code is only structured for small amounts like what I already said. So it means that we're going to need to unfortunately restructure our code and figure out some sort of way to easily enough determine whether we got a good B or bad B or what the B, I have no clue. This is going to be interesting because currently my code is structured so that all you save is the IO expander, which is going to be a bit of a problem seeing as, well, if we have only the IO expanders that we currently have, the maximum of 127, we won't be able to fit enough Bs to have cover all the current iterations of the mod. That is not acceptable. So I'm going to have to find out some sort of solution that we can add to our B thing. Probably just a simple thing in our, basically our B quantification, so to speak. I'm going to look over my code, see what I can change, and then I'll be right back. So this little unfortunate thing, yes, let's go with that. It's, well, as I said, it's a little unfortunate in the fact that we will have to restructure our code slightly. Now, I believe the only thing that's actually affected, well, there are two things that are affected. One, the size of the array for the Bs that is required is increased by 1, but thankfully we have just enough room. I believe it's 15 cells a lot right now. I cannot verify that as of right now, but I can probably look at the footage and check that out. So we have 15 cells. Originally 14 in my diagram was occupied, but we had one extra space so we can put a wire in. Now, this only affects display.p because, well, as you see, it is a little affected, seeing as it's assuming that if you do at the B, you are going to be well off. Now, I'm going to structure the code like this. I'm going to have it so that if you construct it, you don't necessarily have to have these levers. So at any time I deem it like having the function where you can just flip a lever to get everything is a little cumbersome, we can just remove that. And we can also have it through this structuring, have it so that we can remove a light level. That probably won't be too necessary, but anyways, let's see what we need to change. So in our change of structure, 0 is our IO expander, 1 to 10 are our combos, we'll keep that, but 11 we'll put as the initiating wire. So in this case, our initiating wire was white, which was 1. That's fine. Now if we have it as 5, then we need to move to the next one. It'll be 1, 2, 4, 8, 16, and 32 would be our initiating wire for the next line. But we'll put it as 64 for now so that we have access to our levers if need be. So 64 will be our initiating wire. Point in case, or case in point, whichever you want to say, 11 is going to be where our wire is. So we need a way to display a B if we give the address to it. So let's do let's do this. Display B. It'll be a subword kind of. So display B, we'll need to duplicate the B, and then we'll take the IO expander and we'll use it. Now we need to, B is left on the stack, so we need to get the number from it, the wire number. And because of how this is, we're going to have to take the I. Ooh, that's going to be a problem. This is not going to be a subword in the sense that we can't just use it at willy-nilly. So we're only going to have it structured within a word, so let's get out of that. Forget this, let's see, it'd be help if we don't have our caps on. I'll rewrite display.p and add the change in, and I'll show you while I'm writing the change in. I think that'll work. Okay, here's where it changes. Right now we have one of the parents on the stack. Actually, we have both parents on the stack, but we need to... Okay, let's just go through it and edit it. So instead of we need to duplicate the B that we have and get its IO expander. And do that. And 11 cells plus this gets the wire. Now, what we do is do the 2i this, so the power of, actually it's 1i. Thanks for catching that, random stranger. And then we multiply those two numbers together because all the wires are to the power of 2's of one another. So and then IOX set. That's good. Now we're going to need to do the same for the other parent, but seeing as we haven't got the information for the other parent yet, we're still going to have to do the I2 times 2 plus cells thingamabobber to get it basically out of the dang machine thing. Anyways, so it's I2 times 2 plus cells plus and instead of the other we still do the odd thing that we had. Plus 1i exclamation and is that all we need? Then loop, and we don't have enough room. Ew, crud. If this works, I'm going to be happy. If it doesn't, I'm going to be angry. You better hope it works. And it doesn't work. Okay, so I'll just rewrite this and hopefully it'll work this time. Okay, so it's kind of a good thing that we messed up because I forgot a multiply sign. So now the problem is I did go, while it was compiling, create some cyan and purple wires since those were needed as well. And now the issue is with how our wiring is set up is that we're going to have to figure out a better way to wire this. Dang, this is going to be a bit of a hassle. We might have to forego the levers in the meantime and figure out something else along those lines, and maybe it would have been good to have something like that. Anyways, so how are we going to connect everything? Probably through doing this. If we connect it like that, we might be able to get the wires to interconnect without destroying everything. Let's see. Let's get all this, this, because we need this one to pretty much be the same as that, unless we know that won't work either. There must be an easy way to do this. That would be a good way. There's those, not those, I can't think. These things, yes. Let's get these, and rig these up properly, like that, and get those back. And we got a few extra of those, and now set that up. Go around cautiously, and we need 3 of these. So 1, 2, 3, please. Thank you. And they're connected. Now, obviously, the lime is not connected. That we can't really do. And basically, we can take... What? Did you see that? I'm getting 2 per. That's just not right. Yeah, so I broke it 5 times, so there we go. That's just cheaty. I am not a cheaty pants. I do not like cheaty pants. They are uncomfortable. So, now we know what we need to do. We can get rid of these as well. And use less wires in the meantime. Now, that being said, we still need to get rid of these wires in return for the other wires. So that's going to be an annoying wiring setup. So yeah, I'm going to work on that. Hopefully we get it. We'll be able to actually test the code, and we are going to need to change our bees. So all the bees that are currently entered, I'm not sure which they are, but we'll pretty much need to redo them so that we start from scratch, and we're not going to be a flaming pile of idiot. Not a flaming one. I do not want to flame much. Okay, so we got all that wiring done. Now, in the meantime, I think it's a good idea to wire this thing up. This thing is going to basically have all of the, temperature controls. So this will be icy, etc., and arid, damp, and all that fun stuff. So let's wire that up. It's going to be easy enough to handle. So this is what I originally crafted those few wires for, by the way. This is also going to be a bit of a hassle in the sense that I do not have... it's not very easy to go around with these. Anyway, so we got some of that here. Yep, we need to go over here. And we'll put it down what wires what in the future, and this will be for later. And I think there's only 3 more colors left that we need to worry about, which is the pink, the gray, or rather we have to do the gray, the light gray, and the cyan because we don't have enough pink, which is a bit unfortunate. So this, and we'll need that. This, there we go. And finally the cyan, which will just go like that. So all those are connected. We'll be able to develop an easy enough method to figure this out. Actually, it's a very easy method that I think I've devised already. So we'll work on that. So now I'll just change these IO expanders so that it's ascending 3, 4, let's see, 3, 4, 5, 6, 7. I'll quickly, 8, stop that ram. Stop ramming into me. That's not very polite. I'll just quickly do that. Then we can actually add a few bees and then test out our display. Okay, so I'm manually adding in the cultivated common and etc. I'm just modifying it so I don't have to create new bees or etc. I might have to recode the stuff so that the wire is in the 1 slot, but for now I don't think that'll be necessary. So let's see, common display .p. Okay, it shows that. That's good. So let's remove all. Did I put that as an extra word? Let's check our words. So we forgot display. Words, please. No, it's reset all, duh. So reset all, and we need to do cultivated display.p, and it probably didn't remember all the keys I typed. And this is a very long process, I gotta say. Display.p. No, that isn't what we asked for. Let's see. It went over one. So, modest. What is modest and what is common at? This should be at 4. It at least got the any hive bee. So, let's see. What do we have here? Good, 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 good. Okay, we got the right wires. So, underneath it's showing that the 4 IOX address is on right now. Sure, but it's not the correct ones that we're looking for that are on. If anything, let's see. This should be shifted over there, if anything. No, this stuff should be right here. And this common one, this is for cultivated, right? Cultivated, yes. Okay, so that's correct, but these are shifted over wrong one. So, not sure what that is. Let's look at the code and see what the reason is. What the reason is probably not with the code, but modest. I didn't change modest to be this. So change modest. There we go. And let's speed up reset all so that it's 127 instead of the 255 we thought it was. As you see, there's no magic in reset all. But let's see, it should have... Oh, we killed it. We killed it, I see. That could be a problem. Don't worry, don't mind me. Start. Now, did you completely... Yep, you died. Okay. That wasn't supposed to happen, by the way. Yeah, I completely goofed. So, I'll be right back after, again, re-inputting everything. Joy. So, after finally putting out our fire... Please work, please work, please work. We then realized we forgot one important part, which was the I in front of the IOX address. Please work. Thank you. So now that that actually works and it's going to be a bit more speedy, see, it's already done. We'll re-input our hive information and then we can finally start with our temperature tolerances and etc. And this just to prove that it actually works. Cultivated display.p. That wasn't planned. One moment. Okay. I realized what the issue was. Why I couldn't get cultivated to show at all. Had to type it through 3 times to figure out. When I rebooted from the disk, I forgot to add the combos in. That just sucks. Anyways, so we got that figured out. So what I think we'll do now is actually try to figure out how to display the temperature readings. So what we need to do is figure out some easy enough way to do so to make sure that it's both easily editable. So say your wires just are completely different, we can edit that. And basically add in other things as we go along. So let's add in a variable iox.t. And what this one is going to be the iox address for the thing over there, which is 127. Which is easy enough. So let's just do iox.t at iox address, exclamation mark. And what we'll do with this is turn on white. which happens to be blue in our case. As you can see, the little pixel over there indicates that it is working, woohoo. And reset all will work on it. So if we just watch and wait, eventually it should get to that point. It's the very endy one, so let's just watch it. Please. Oh, you gotta be kidding me. Ah, dang. I'll edit it. Okay, we got it. It was 127 beforehand, and just in case, what we're going to do is save it so we don't completely kill our system again. So let's reset all, and eventually it'll actually turn off that blue light. If it doesn't, we can just chuck a rock at it. There we go. So what we want to do is be able to have some sort of temperature that will be able to display as well on the board over there. So what we need, hey, I didn't say you could go there. I probably did, but I didn't know any better. So let's see, we need almost like an address for each and every single temperature that we have. So like a variable for normal.t or normal t, and a variable for each of them. So for there's normal, we're gonna have to take our apiaries databank out. So let's see, we can look at our leaden one and check which each of them are. We have cold and icy, normal, warm, and hot. So let's add those variables in. And there we go. So for each and every single one of these, we're going to need to get the appropriate wire and put that number as what its value is. So 1, 2, 4, 8, 16, 32, and it then it skips 64, then it's 128. So we don't need to do too much for that. So I'll enter those in manually so we can skip that part and then continue on with the more fun stuff. Okay, so there we go. We got everything that we need. Now this stuff shouldn't apply at all to our any hive bee, because frankly that would be stupid, because any hive bee is different from the other stuff. So for instance, let's see, modest. All of our temperature information, I believe we should store it into, the temperature stuff will be in cell 12, and the humidity will be in 13. So set temp will have a more robust way to add information to each bee later on, but this will be good enough for now. So we don't have to retype everything each and every single time. I also added a wire exclamation mark for the bees, though that stuff should be hidden when we get some sort of set B command that just enters it all in. It'll be a lot better. So set temp, set humid. We need that as 13 cells plus exclamation mark, semicolon. Because, you know, semicolon. And these will store the addresses. For now, I think it's best to store the addresses of this stuff, so the normal T, etc. But then in the future, well, we can set up the code so that it'll be able to handle this, but have it so that it does a range. Now, the temperature range will only come into effect really when we get to the more advanced stuff, such as having all of the biomes. I think I already have that stuff handled, but let's see. We want to add, let's go for the common stuff first. Common, I believe it has only normal and normal. So let's see. I believe we'll put it as temp, which is how it is. Okay, so normal T, common, set temp, normal H, common, set humid. There we go. That should all be saved into the B now. Now we need a display.t. This will display the information of the temperature. So we'll duplicate it twice so that we have the B a lot of times. Then we need to extract the information from the temperature, cells plus at. And since this only gets the address, we need to do at again. And let's swap it. Then we go 13 to get the humidity. Now we have the B. Now we have the humidity address. Now we have the actual humidity. And add them together. And then compile. Okay, so this should give us the wire, what we have right now, by adding up those two values. Then we'll change the expander to this, the one we determined before, and then finally IOX set. We'll turn those on. Now, does IOX set work for multiple wires? Oh dear, does it? Does it? That's a problem. And I should have checked that beforehand. No matter, if this doesn't work, we'll change it to IOX exclamation mark. It might not be as robust, but whatever. Whatever. Let's see. Common display.t. Please work. Yes, it works. It works. We got our two wires on, showing that these are the correct temperature tolerances. So it shows that by default, common is normal and normal. That works. That definitely works. We might be able to have a more robust system in the future, such as adding like a dual tolerance thing. So let's check cultivated. Cultivated might be a good thing. No, it doesn't have a good bandwidth, nor do any of these. Only when you get to the rocky stuff does it have a huge default bandwidth. Except this one. But it only has like cold stuff. Though marble, is there any one that has a default 1 in each of them so we can show it? Let's just change our common. So let's add a new variable. This variable, that would have been helpful if we actually had something. Okay, variable, we can't really name it variable. Let's see if that did anything. Check our words. No, it doesn't look like it. Okay, let's add variable. Normal T dot B1. So normal T dot B1 will be normal temperature in both directions with an extra tolerance. So that means it'll be the normal and those two extra. So what that means is we need to get the the cold, and get its value. We need to get the normal and its value. And we need to get the, hot, warm, its value, add. So we got one value combining all those wires together. And then what we do with that is put that into normal T. .b1. Might be helpful if we actually got it correct. I suck today. Shush. There we go, and it should work. Now all we need to do is set temperature for common. Yeah, let's put it for common. So set temperature for common as normal T.b1. There we go, and let's do the common display.t. Crossing fingers. There we go. That is exactly what we wanted to do. Now obviously we can change the address at a later time if we so choose, but these are working, so we can probably, we need to add another light in there. I can probably add that, I will add that easily enough, so we won't have to worry about that for much longer, and probably pretty it up. Now the thing we need to worry about in the future, making sure we actually have some jetpack fuel, is where to put our products table and our biomes table. I'm thinking our products will be on both of those walls, because I don't think there's necessarily as many of those as our biomes, which might need to inhabit all of those walls. Or we could have it temporarily over there, though that might not be as fun. Now, I'm thinking to make it so that we don't have any, like, a lot of difficulty adding new biomes in the future and having to have, like, for instance, let's look at our rocky drone. There are a few things that the person might want to enter. One, they might be okay with entering all of this information for its default climate. That's okay. Having the person enter in all of the biomes, on the other hand, might not be so dandy. So what we'll probably have is have some sort of algorithm that will be able to determine easily enough from all the climate information the biomes that will be required. Now, the biomes themselves have to be entered into some sort of database, so we'll be able to just pick and choose. Let's do reset all, please. But I think it is doable. That is the point. If it's doable, we'll do it. If it's not, well, screw it. Well, due to all of our screw-ups that we managed to pull off this episode, hey, coding is serious business, guys. We're probably going to have to cut it for today. We definitely went a little overboard with the time, though it's not too bad. Now, in the future, what I'm going to ask you guys this. Would you prefer me to have like a very long, hour-long episode to get the coding out of the way so you don't have to watch it, or would you prefer having the 30-minute episodes and then just watching me, fail? Yours to decide. Well, that's all the time for this episode of EEPower. If you like what you see, don't forget to rate, comment, and subscribe to future episodes. What I'm probably going to do in the meantime is set up some sort of wall and get enough lights and possibly get some sort of bag to hold these wires. You can tell I had enough caffeine because I am so wired. WayofTime here, signing off. Have a wonderful day.